Hey everybody, welcome back to Young Engineers of Today. I hope you had a good couple of days, and I hope you are ready to continue with 123D circuits. Now, today we're going to learn the PCB aspect of 123D circuits. We went over uh, the circuit building aspect of it, I guess, for lack of a better term, and now we're going to get ourselves familiar with the PCB aspect, which is a little bit more involved, just a little teensy bit, but it's not too bad. And it's something we'll probably be able to cover in its entirety today. Certainly, hopefully. I've been wrong before, and it certainly won't be the last time I'll ever be wrong if I'm wrong today. But um, it's not too bad. And then if time permitting, today we'll go over exporting it as a Gerber file so that you can load it up into other plan and you know set it up so that you can print that stuff out, or rather mill that stuff, cut it, etch it on a CNC machine. Otherwise, though, we'll at the very least get ourselves more familiar with the PCB side. Yeah, other than that, that's what we got planned today. How's everybody's week been so far? Been all right? Well, that's good. Okay, so let's go ahead and go to 123D circuits. Excuse me, cat. I'm just going to spend some time deleting the designs that I have here. If for no other reason than just sort of clear up my my dashboard. Yeah. Sure. Sorry about that. That is the link to get to 123D circuits. Very insistent cat right now. He really wants to go outside. He hears people talking out there. But alas, he cannot. Give everybody a moment to get onto 123D circuit and get logged in if you aren't already. If this is your first time logging into 123D circuits, keep in mind you can use your Autodesk login that that you used for Fusion 360, thanks to um, thanks to you guys last time around who were on the ball enough to realize that and kind enough to let me know. Okay, so I'm assuming now that everybody is looking at this page, at least in some capacity. So what I'm going to do is I'm going to show you how to get a new PCB started. Real easy. In the upper right-hand corner, there is that new and the plus. I'm just going to go ahead and click on that. Boop. Notice you got new electronics lab, new PCB design, new PCB component, import equal project, new circuit scribe, and new mesh GPIO PCB. We're going to get ourselves familiar with PCB design. So go ahead and click on new PCB design. It's going to spend a couple of minutes thinking about things. And then it should, yep, bring up a blank window. So now we've got, once again, the unnamed circuit, the dramatically named unnamed circuit, with this little icon over here representing that it is a PCB design. We've also got a few more icons in the upper right-hand side than we did in circuit design. We've got schematics view, PCB view, bill of materials, and settings view, which we will look at least a couple of these in the next hour. So from what I gathered on Monday, you guys are at least to some degree familiar with circuit design. So you don't need me, telling you necessarily how to do it. What we're going to do is we're going to create a circuit that is a little bit more complex than the one we made on Monday. It's still going to be a very simple circuit, but it's going to be a little bit more complex, and it'll be a little bit better for showing off what the PCB is good for. So what we're going to do, as we always do, first things first, we're going to add a few components, because you can't do much if you don't have components on there. And you'll notice that all of these components are schematic icons. They're not actually little illustrations of the components like we have in the electronic circuit design. These are simply schematic representations of them, which for right now actually serves our purposes pretty well. So go ahead and grab the ground, drag it on, grab the VCC, drag it on, grab a resistor, drag it on. We're going to find LED, which usually involves a little bit of scrolling. At least it did for me. It may not now that I actually used it once. Oops, I did not mean to do that. You can always hit the delete key in order to get rid of something that you accidentally put in. We're going to have a second resistor, but I want to get the LED on there first. And you guys let me know if you happen to see it on my screen. I know there's a bit of lag, but I also have the GoToWebinar window entirely in the way of at least one column, no matter where I put it. So hardly ideal. Aha, here we go, LED. And you'll notice as I drag it, it gives me lines so that I can line it up with other components on here. That's good. Go ahead and line it up with the resistor. And then finally, we're going to drag on a potentiometer standard panel mount. For me, that was in the second row. It looks like a schematic of a resistor with an arrow pointing into it. So go ahead and drag one of those on there, and we'll bring that in, and that's all good. So now if we click out of the components tray, it will minimize the tray, which is exactly what we want. So now we've got our VCC, which represents power in some capacity, usually a battery since it's not AC. We've got resistors, a resistor, we've got an LED, we've got a potentiometer, and we've got a ground. And these are all the things we're going to use to get our circuit set up. So I'm going to go ahead and drag the ground down. I'm going to bring down the potentiometer, and we'll rotate it. Don't worry, this is not incredibly intensive stuff right now. I just want to get everything aligned properly for what we're about to do. So handy trick, if you hold down the Shift key and drag, you can create a selection box and thus select multiple components. So that's what I'm going to do. I'm going to select both this resistor and this LED because I want to create a copy of them. Control C and Control V should give us a copy, which we can then bring over to the other side. So now, predictably, I have two sets of a resistor and LED. And everything else that we need right here. Now, none of it's connected, which is fixable. That's okay. There's actually a really dead easy way to fix it, and it's exactly the same way that we hooked everything up on our breadboard in the circuit lab. You just simply click on one thing. Notice that I got like a little red square there when I moused over it. Go ahead and click on that. Now I've got a blue line coming off of it. This allows me to create a connection between two things, as one might expect. So go ahead and create a connection from the resistor to the power, and then do the same thing with the other one. Now we've got these connections. Go ahead and connect your resistors to your LEDs, and then your LEDs to the potentiometer, and the potentiometer to the ground. Cool. So this is the beginning of our circuit. We've got power, resistors, LEDs, potentiometer, ground. Can anybody take a stab at what this circuit might actually do? You'll notice that I can drag it, and the connections remain where they are until I'm done dragging it, and then the connections update. So you can still move it around. Yeah, we'll turn on the LEDs. Anything particularly special about what it does? Maybe like what that potentiometer is for? Show of hands, how many of you have seen a potentiometer or used a potentiometer? Okay, well, one person. All right, so maybe a potentiometer isn't the thing that you're as familiar with. Well, a potentiometer is just basically a fancy name for a knob. And what the knob does is it changes the resistance coming in from either side and going out. So essentially, a potentiometer creates connections in this direction. Even though these two are connected across this way, the power isn't meant to flow this way. It's meant to flow from either side down, into here. Or, up as the case may be, as it looks in this illustration. But regardless, it's meant to go one way or the other. The knob will sort of determine whether it's going to come, whether the resistance is higher on this side or on this side, or it's equal or whatever. So in essence, what's going on here is power is traveling from up here, down through the LEDs, and then down onto the ground. You twist the knob on the potentiometer, maybe you raise the resistance on this side, and thus lower the resistance on this side. So more power will travel this way, and this LED will become brighter than this one. And you can twist the knob the other way, and the opposite thing will happen. So basically, it's just a simple little circuit that allows you to select which LED is going to be on, one or the other, or they might be of equal brightness or whatever, since this is an analog circuit. But yeah, that's all it does. Now, I should mention that there is one more thing that we're missing. Right now, this schematic represents an entirely sort of closed circuit. And these two things here, the power and the ground, are really more symbolic than anything else. There's actually, if we were to go over to the PCB side of this and take a look at it, there would be no connections on this board for either of those things. So in that sense, it would be assumed that the power is hooked up somehow, somewhere, some way, even though it's not allotted for it on the PCB. So what we need to do is we need to make a way for us as, humans beings to hook up power to our board. So we're going to go back into components real quick. And we could go hunting for this, but we'll just use the search function in order to make our lives a lot easier. We'll go to board, type in board, and you'll get no results. Cool. All right, so I'm going to look for this the hard way. Oh, because I needed to search for block. A derp. Okay, so I've got this connector, comma, screw terminal block. This is the thing that we need. So I'm going to go ahead and drag this out over here. And then click off the menu again. So now we've got this. So what exactly is this going to do? How is this going to be helpful? How are we supposed to hook anything up to this? Well, it should be said that 123D circuit can do some very useful things. For this particular instance, if we were to create copies of both this power and the ground, and name them the same thing, the result is that there is a connection created. It's assumed that that they are the same thing. So, like, in essence, I'm trying to think of an example here. So maybe you've got, I don't know, like one of those weird mazes that they have on like cereal boxes sometimes, or in like books, where things lead off to whatever. This is the worst maze ever, but bear with me. And they might have a symbol at the end of a particular pathway, and then elsewhere in the maze, they've got a copy of that symbol, and the path continues. What this means is it's assumed that like the path continues as normal. Like the same thing if we were to basically take this and just move it right there. It's meant to represent the fact that they are not just connected to one another, but like it's a continuation of that connection. So that's what the implication is here with these. So if we were to make a copy of these, like I'm about to, just using Control-C and Control-V, and rotate it around, place it down here, hook the two up. Let's go ahead and give these the same name in the menu over here. So we'll call this VCC 5 volt. Hello? 5 volt. And we'll do this, the same thing with this one over here. Simply because it's also useful to give them helpful names, so that we look at it and we go, okay, yeah, this is meant to be a 5 volt connection. We'll do the same thing with the ground. The ground is already labeled 1 on both of them. That's fine. They both have the same name. The VCC both have the same name. The VCCs both have the same name too, which means that this is all connected. So the screws provide an outside place for us to hook stuff up. Like what they represent are holes in the board that we could literally plug things into, like a battery. And then the connection runs from each screw to their respective spot on the circuit. And then the circuit is, the circuit can do its job by getting power and having a complete circuit. Sorry about hitting the microphone. So for all intents and purposes, we now have a complete schematic. It's a very simple circuit. It does exactly, I explained it was meant to do. Oh, okay, your computer was loading that whole time? Gotcha. Well, in order to do a new one, if you log into, are you already like on a blank circuit, or do you need help getting to that? Sorry, yes to which? Oh, okay, gotcha. Well, I'm gonna move the mic up a little bit. There we go. That should be a more reasonable volume. That would. Why don't we? Just because that's gonna take a minute. In fact, it's gonna take exactly as long. If you want, I can pause the screen for a little bit. Oh, no, my screen is not paused. Okay, I can pause the screen for a little bit, And so you can look at what we've got here. The rectangles with the R's next to them are resistors. The squiggly line with the R next to it is a potentiometer. And then the triangles with the arrows are LEDs. So at the very least, you can get like the beginning schematic down, and then we can go from there. I'm sorry, I didn't realize that you're... No, it's fine. I apologize. I didn't realize you were still loading 123D circuit there. I would have waited a little bit longer in that case. That's not exactly helpful for you if you're waiting for it to load and I'm going through the entire lesson. So I apologize. I could have waited a little bit longer on that. Okay. Well, I'll make sure to get this one up first tonight, then definitely, and hopefully it won't take me hours to get it uploaded like all the other ones have been recently. Yeah. So anyway, yeah, no problem. This will be our complete circuit, but this is only half the job so far. There's another aspect to this. We actually have to lay out the board so that everything can fit on the board and the circuit can operate as expected. I mean, it's this right here. This is not a visual representation of how everything's going to look on the board. In fact, this is just meant for us so that we understand what the circuit is supposed to do more easily. However, if you look at real life circuits, like how many of you looked at a circuit board and seen all those, all the elbow, little bits of metal and stuff like that running along the circuit board and going off and spidering in different directions and doing all kinds of crazy stuff. I assure you that looks nothing like the schematic. If you were to, pull the schematic and take a look at it, it's one thing to design the circuit, it's another thing to design the board, because then you have to figure out how everything fits on the board. So that's what we're going to do for the second part. So if we go up here to the upper right-hand side, we've got Pcb View, which is the second icon. If you hover over it, Pcb View shows up as a little tooltip. Go ahead and click on that. And then you got this mess right here. Like all this, wow, what is that? What is that? That's terrible. These are all the components that we had over here, all layered on top of one another. The, I believe, industry term for this is rat's nest, because it's just a crazy mess. So what I'm going to do, and what you should probably do too, is I'm going to spend a little bit of time just kind of clearing all this stuff and giving everything a nice, neat position. I'll put this up here. There we go. I'll bring this resistor over here, maybe pair it up with its diode. And I'll bring this resistor right here and pair it up with its diode. And we'll move the potentiometer over to the side a little bit. Now, before we do anything else, I just want to make sure everything's in the right spot. So, and these are going to look different. See, what these represent, these two squares right here, like on resistor 1, these represent basically connections or like holes in the PCB where we can add components. Like regular old breadboard components. Maybe we want to change the type of resistor that's in there. Not the ohms or anything like that. Ohmage. Whoa, bro, sweet ohmage. Anyway, not the ohms or anything like that, but maybe we just want to assume that like our PCB is going to be a little bit cleaner than it normally would be. So I'm going to, if I click on one of these components, we get a menu up here just like we do over in circuit view or schematic view. There's this button here though, change footprint. What that does is that changes how it looks. And that is significant because it can more closely resemble its real-world counterpart. So I changed the resistor to I'm going to change both of the resistors to I can't remember the name exactly, but once it comes up I can tell you, to P6013/15, which is a really unhelpful name, but that's basically just the the size of the resistor, the footprint, if you will. Come on, there we go. And I'm going to do the same thing with the LEDs. I'm going to change them to 5mm LEDs. So do a search here until you see LED 5mm. 10mm is too big, 3mm is too small. Aha, here we go. This one right here, it's got like the little sort of half or bit of a circle here, and it's labeled LED 5mm at the bottom. That's what we're going to change the LED's footprint to. We'll move this one a little bit over here. We'll change its footprint also to 5mm. I'll just do a search for it to make my life easier. And it totally didn't search for it. There we go. All right. So it's the one with the larger circles. Cool. So now we've changed the footprints appropriately. Let's bring that up a little bit. I think this is about as small as we can make it. We might be able to make it a little bit smaller that way. Yeah, let's do this. Let's do this. And then we'll bring the resistor down to right here. Some of you may be wondering why I am fretting about the orientation of everything. And I'll be happy to tell you. It's because printed circuit boards cost money based on how big they are. So, I mean, obviously, because you have to use more material. And it's not just like, you have to use more material. It's that you have to use more etching solution. You have to use more copper. You have to use, more of the board material. It's more expensive all around in order to manufacture a larger PCB, more so than you might imagine. So I'm kind of grouping up everything incredibly tightly so that I can take these edges of the PCB and bring them in. And you'll notice up in the upper right hand side, I can't let go of the mouse, otherwise it goes away. Price for 3 boards right now is listed at $25.65, which is down from where it was before. Now I drag this one over the side, and you can see it going down. I have a lot more freedom in changing the shape of the PCB, like a surprising amount of freedom in changing the shape of the PCB. I can, make it all weird and skewed like this, or I can double click on this and put in a curve, make it a nice weird sort of blobby kind of shape. Really and truly, if you need a specific shape for a PCB, chances are by messing with that curve function and skewing and changing the walls and the fact that you can double click on a wall and add a new point, all of those things you can use those in tandem in order to generate a useful shape for you. So now, we've got the PCB size down, we've got the orientation of the components down. We're done, right? Well, no, not really. There is one more thing we need to do. A couple more things we need to do. First off, you may notice that we got all these green lines here, right? I mean, that's pretty obvious. They kind of stand out. The green lines represent the connections between each of these components. However, they're not exactly legitimate connections right now. What I mean by that is they don't actually exist on the board. They just represent where everything is supposed to be connected. They don't actually represent how everything is actually connected. We're just saying like, oh, hey, the VN is supposed to be connected to this resistor and also to this resistor, and then this resistor is supposed to be connected to this LED and then to the potentiometer, and then this one's supposed to be connected to the potentiometer and also this resistor. But like, there's no actual copper tracing that we've marked yet in the PCB. As it stands right now, this would be a completely blank PCB with just some stuff embedded in it, and nothing would be connected to anything else. So what we need to do is we need to create those connections. And it's pretty simple. Over here on the left-hand side, we've got this one button here, copper trace. I wonder what that could be. Well, let's go ahead and click on it. Now, before we do anything, there's this drop-down menu here, which can change the size of the copper trace, basically the thickness. The thicker it is, generally the more power it can handle. Because, it can dissipate heat better, and it has lower resistance, and it's just all around, it's better for larger amounts of power. We're gonna go up to the 20 mil or the 51.51 millimeter option, because we want to make it a little bit thicker. And we're just going to start by doing a connection from our power screw to our first resistor. And you notice that as I move the mouse around, I got sort of this wibbly elbow put in here. This is meant to represent, the path of the copper tracing. And if I hit right click, I can change the bend of the elbow. It can be a 90-degree angle instead of a 45-degree angle. It can be up, it can be down, whatever I prefer. I'm going to have it be like it was originally, so like this. And I'm just going to go ahead and click on this right here. And as you can see, we've created this connection now. We see that it's red. It's running from the power screw hole thing to resistor 1. And then we can do the same thing. We can run from resistor 1. And if I click once, it puts in one part of the elbow. Now you notice I can still, it only put in that one line there. So I can still affect the final shape before I, click on this one here. So now we've got the power hooked up to resistor 1 and resistor 3. Now we can run power from resistor 1 to LED 1. However, there's a bit of weirdness here. See, all this copper is meant to be on the top of the board, right? But we're going to have a fair amount of overlap between resistor 1 and LED 1 without some really careful maneuvering, which is not generally a huge deal, but let's just make our lives easier. So all circuit boards, not all circuit boards, but most circuit boards, any circuit board that's really worth it is going to have multiple layers to it. Multiple layers that can be used for wiring. This allows the complexity of the wiring to be greatly increased in a smaller amount of space, because now you're using 3 dimensions, now you're thinking with portals. But actually it's, I don't know, kind of makes sense. The portals reference. Anyway, let's go ahead and click layers up here in the upper right hand side, and now we can see we've got 2 layers, top and bottom. Top is red and bottom is blue. Hey, look at that. You'll notice that when I click on top, this nice red line is coming through nice and clear. When I click on bottom, the red is a little bit see-through, and now all of the holes are blue. This means that this layer of copper, as you might have guessed, this trace of copper is on the top of the circuit board. However, we are currently looking at the bottom. So let's run a wire from the bottom, or from the resistor to the LED along the bottom. Best guess. Perfect. Undo. So as you can see, I got a yellow area there, which means that there is overlap where there shouldn't be. Or there's some sort of error with the PCB. design that we have. In this case, it was overlapping with the other hole on the LED, creating a connection where there shouldn't be one. See, I updated it though so that it maneuvers around that connection. So now there's no issue. So if we go back up to the top, now the blue becomes a little bit more transparent, and then the red comes back, signifying that we know that this connection is on the bottom of the PCB board. The PCB. Sorry, PCB board is redundancy. Let's do a similar thing with resistor 3 into LED 2. Well, bam. And then back up to the top. Cool. So far, so good. Now, we can run it from the LED to the potentiometer. But let's do something a little bit fancier. Let's say we wanted to start on the top and then run it along the bottom in order to, the copper trace, in order to sort of maximize the amount of maneuvering we can do with the copper trace. So we'll start on the top. We'll start to bring it down like, we'll bring it down, may have made my life more difficult. Bring it down to here. So we'll click twice. And then what I'm going to do is I'm going to click on the bottom layer here. Now, as you can see, we've got this little circle here. That circle represents, in essence, a connection between the top layer and the bottom layer. We'll go with a straight 90-degree curve. Click, and that should create our connection. So now we can see that the top bit is see-through, and now the bottom bit is see-through. There is a connection made. It starts at the top here, hits this hole, runs to the bottom, and then continues along. And this ensures that, we maximize the amount of space we have in order to work with. So let's do the same thing up here. We'll start up here. We'll actually make this a bit of an impressive maneuver. Go to bottom, run underneath. And run it to there. And of course, we ran into a couple of issues because there are some connections here which shouldn't be there. So let's try it again. Apparently I'm very bad at designing circuits. And voila. We have successfully layered our connections so that they don't run into one another. And we've managed to connect this whole thing together. Well, I say whole thing, but there is one exception. There's this bit right here. However, does anybody remember what this connection is supposed to be? What these are both meant to be connected to? Well, these are both supposed to be connected to the ground, right? There is a better way to do this. We're going to take a look at the copper pore function on the PCB creator. Now, copper pores, basically what it is just an area of solid copper on the PCB. It's useful because it saves on the amount of etching solution necessary in order to create a PCB. And also it can act as an energy dissipator, or a ground. So what we can do is we can create a copper pore throughout this entire PCB that will then serve as the ground, and it will also serve to connect both of these. So let's go ahead and take a look at how that works. Copper pore is pretty dead simple. Basically, you draw an area around where you want the pore to be. And that's it. So what I'm going to do is I'm going to start it by clicking in this ground area over here. What that's meant to signify is that this ground will be connected to the copper pore. By extension, anything else that is connected to this ground, it will also be connected to the copper pore. And you might, if that doesn't make sense now, you'll see what I mean in just a second. Let's go ahead and click and create our start. And as you can see, all I'm doing is I'm just drawing an outline around the PCB. Simple as. And then once I complete the outline by clicking back here, you'll notice that will complete the loop around it. It'll take a second to think, and bam, all of that will turn red. Now you'll notice that there are these unbroken sort of outlines around these areas. These represent the fact that they're, basically that area is going to be etched out when the PCB is made. So that means that there will be no connection between this material right here, and these connections, I really need a better color than purple, between this area right here and then these connections. There is no electricity flowing between the two. However, if we were to zoom in and look closely at this ground area, you'll notice that there are some breaks in that outline. This means that yes, it is connected. And if you were to look at this physically, there would be breaks there too in order for that connection to be created. Same deal down here on the potentiometer. You'll notice that the third connection, which is supposed to be connected to the ground, is connected to the copper pore. It is in fact part of the ground. We look at bottom. Bottom is unaffected because it's on the other side of the PCB from the copper pore, but we have created our ground. Excellent. This will ensure that our circuit can be completed. We just hook this up to something else, and we hook this up to power, and we can use our neato little schematic, or neato little circuit, I should say. That's a much better way to put it. But that's it. We've designed a printed circuit board. That's all there is to it. I say that's all there is to it, and it took us a while, but it was, it was meant to be an exploratory process. We were meant to look at this and figure out how to do it, with lots of explanation peppered in. But really and truly, it's actually not that bad of a process, and it's kind of cool. Like creating it's kind of like a puzzle. How are these connections all going to sort of fit together without, overlapping or touching in a way that we don't want them to? How are we going to fit all these components onto the smallest possible printed circuit board? Whatever the case may be. In fact, we could trim this down even more by bringing, the edges of the PCB in along the side here. And that would save us even more money. If you were so inclined, you could do that. But as it stands, we've got our completed PCB. Well, now what? Now what do we do? What do we do with this now? Well, I'll tell you what. First, we're going to save it. We're going to give it a name. If you click over here in the unnamed circuit, you'll notice it turns into a link. You can click it and give it a name, like Super Sweet LED Chooser 9000. That gives us a more, I guess useful name is not really a fair way to put it, but it gives us a more colorful name. You could probably name it something useful if you were so inclined. You could put in a summary, a description, you could put in some tags, you could invite somebody to take a look at it, like a particular user, whatever you're whatever you need. You could make it available for the public, give it a nice, basically the license means that if you're ever curious about the licenses, you can look them up on Wikipedia. But it's meant to be as open source as possible, in essence, really. I mean, it's meant to be, like, that's part of the point of 123D Circuit, is the fact that people can create circuits that are then shared publicly that other people can then use or improve upon or whatever. It's all meant to be a big, sharing and caring kind of idea. But anyway, we've saved our circuit. If we wanted to, we could take a look at the bill of materials and see exactly everything that would be needed. So potentiometer standard panel mount, this is a very common, there's the potentiometer Wikipedia example, DigiKey, you can find it on DigiKey, so you can purchase one. Connector screw terminal block onshore technology, here's the listing on DigiKey. Here are the resistors. They're not going to be listed on DigiKey because, I mean, there are a million different places you can get resistors from. And it's just, I mean, really you can find them anywhere. You don't need to go to a specific place in order to find one of those. But these can be helpful because sometimes they're a little bit more obscure. But this gives you a listing of everything you would need in order to build this PCB, not including, of course, the actual PCB material itself. But it's assuming that we handle that. So now what I'm going to do is I am going to click back over here and go back to 123D circuits. That was just the icon in the upper left-hand corner. And now if I click on Super Sweet LED Chooser 9000, give it a minute to load. There's our schematic. We can click over here, see the actual PCB design, and be super impressed by it. And probably most importantly, we can go down here to these buttons: Edit Project, Download Gerber, Duplicate Project, or Duplicate Project, I should say. It's the verb, not the noun or the descriptor, which would generally be known as an adjective, but it's the verb. Share and embed, and delete. I don't want to delete it, so I'm not going to click on that. I don't really need to edit it anymore, so I'm not going to click on that. I don't want to duplicate it. I'm not going to click on that. It's whatever. I'm not going to share it. I want to download the Gerber. For all of that hemming and hawing, I'm sure you guys knew exactly where I was going with that, but I decided to put a little bit of drama into it anyway, so I'm going to download the Gerber. It's going to spend a little while sort of turning it into a Gerber file for us. and then the download completes pretty much instantly. Gerber files are tiny. Now, this is kind of the strange thing about Gerber files. I'm going to show this in folder. Here's our Gerber file. It's a zip file. If I were to double click on it so I could take a look inside, what are all these files? What is this? What is this? We've got a .drl, .gbl, .gbo, .gbs, .gtl, .gto, .gts, and .outline. That's really unhelpful. Well, it should be said that Gerber files, among other things, at the very least, they split up the files based on whether or not they're meant to represent the top layer or the bottom layer. So as you can remember, we had a top layer, complete with copper core, and we had a sneaky bottom layer on the bottom, where we sort of routed some of these connections so that it looked cleaner and also so that they didn't run into one another. GTL stands for Gerber top layer. GBL stands for, unsurprisingly, Gerber bottom layer. Then we've got a few other ones. The order of cutting and everything like that. But these files are pretty much all going to be, to some degree or another, necessary for other plan. So I'm going to extract them into a folder. And I'm going to put it on my desktop. Because I don't have enough stuff on my desktop. Let's be honest here. So there's my desktop folder. I'm going to go ahead and open up Other Plan. Wait for it to start up. Okay, there we go. So we're in Other Plan now. What I'm going to do is I'm going to open up a file. And this file is going to be, hold on. There we go. It's going to be this .gtl file from the folder that I, unzipped. Hit open, and then it's going to ask us for more Gerber files. So it's going to ask us for circuit.gtl, which we already gave it. Make sure that, circuit.outline is selected for the outline file, and that circuit.drl is for the holes, which is fine. We'll hit OK. I'm going to spend some time thinking. Whoa. And here we have a view of the cuts that the machine would make into the PCB. We've got where the potentiometer will be held, how the potentiometer is going to be put in, the holes for the ground and the 5 volts, the resistor holes, the LED holes. So far, so good, right? Let's just make sure. Just want to make sure I'm not missing anything else because I've done that before. Yeah. Interestingly, it should be asking me for a bottom layer, which is what I thought, but it's not. But it shouldn't be a huge deal. At any rate, we've got our holes to drill and our top layer ready to go. And I don't think it's actually going to do any drilling of the top layer. It's not going to do any milling of the top layer, I should say. That we worry about later when we're doing our etching. But anyway, you could start milling this. It'd take 12 minutes and 43 seconds, and you would have a nice piece of copper ready to go and be, and to be made into a PCB. Get it etched, usually involving some kind of acid, which is, it sounds pretty cool. It's actually pretty cool. Remove all the copper you don't need, and then solder in the actual components, and you would have a completely dedicated circuit that is super sweet and would choose LEDs to light up. You could show it off to everybody, be like, I made it myself, I'm the best. Everybody, stand in awe of my circuit designing abilities. But yeah, that would be the way you would do it. So for that, we're going to go ahead and call it a day. I'll go ahead and throw out the poll questions, like I always do. Should be no surprise there. We'll leave it open for question and answer time, like we always do. No surprise there. And then, if you guys don't have any questions at that point, obviously you can head out. But, after that, we'll break for the weekend, and we'll see you guys on Monday, probably to get started with Eagle circuits and continue more with the PCB design stuff, see how that works out. Because Eagle circuit is a pretty comprehensive, tool. So we'll take a look at that as well. And we'll continue on our CNC journey. Anyway, yeah. Poll questions incoming.